Today we're going to have more practice with adding and subtracting rational numbers. Our essential question is, how can you add and subtract rational numbers? So we're going to start with our first rule. It says, what is the rule for adding rational numbers with the same sign? By sign we mean positives and negatives. It says, when you add numbers with the same sign, you just add and keep the sign. This is very similar to how we add numbers with the same labels or units. For example, 2 inches plus 4 inches equals 6 inches. Therefore, 3 positives plus 5 positives is 8 positives. So we can see that expressed over here in the equation, 3 plus 5 equals 8. And if we look at it in a model, if I have 3 positives represented by these 3 positive counters, and I add 5 more positives represented by these 5 positive counters, the answer is represented by my total number of counters remaining. So I have 8 positive counters. The answer is 8 positives. Well, if this works for positives, it stands to reason that it will work for negatives. It says 2 negatives plus 3 negatives. Well, I'm adding things that are the same, so I'm just adding them together and I get 5 negatives. But when we look at it in the equation, -2 plus -3, it's very easy to get confused by the negatives and think that we're subtracting. Just remember the rule. When you're adding things that are the same, add them together and keep your sign. So -2 plus -3, my signs are the same, add my numbers and I get -5. This is best represented by the model, 2 negatives, and I add 3 more negatives. My answer is the total 5 negatives. Well, how does this look when dealing with fractions and decimals? The same applies to decimals and fractions. However, when we deal with decimals and fractions, there are additional steps to take. So with decimals over here on the left, we have a couple rules. The first one is line up decimal points and fill in zeros. This is very, very important because we have to line up place values when adding and subtracting. The biggest mistake that I've seen is when dealing with whole numbers. It says put a decimal point on the end of all whole numbers and then fill in zeros. So if I read my problem, -2 plus -7500. I have to start by making my numbers look alike. So -2.00 plus -7500. My signs are the same, so I'm just going to add my numbers. 2.00, 7500, add, you get 5, 7, 2. I had negatives, I added some more negatives. Altogether, I had 2 and 7500 negatives. Over here on the right, we have fractions. So before we can add or subtract fractions, our first step is to make every number look like a fraction. Again, you can't add or subtract things that don't look alike. So we're going to start by putting them in the form of a number over another. So in order to add fractions, we must also find a common denominator. And then the final step, probably the most important, is to simplify or divide using top and bottom out. Most of the mistakes that I've seen when dealing with fractions is you get an answer, but your answer isn't one of the answer choices. Chances are you still needed to simplify or divide top and bottom out, and I'll model that for you here. So we have -3 1/2 plus -4. Well, I have to make that mixed number into an improper fraction, so it's negative. We're going to multiply 2 times 3 to give us 6, plus 1 to give us 7, 7 over 2. Bring down our plus, -4 over 1. So both numbers now look like fractions. Our next step is to find a common denominator. I have a 2 and a 1. My common denominator is going to be 2. So the 7 over 2 is fine, but I need to multiply the top and the bottom of this fraction by 2. So that gives me -7 over 2 plus -8 over 2. My signs are the same, so I can add. 7 plus 8 gives me 15 over 2. Keep your sign. Again, I have negative 15 over 2. That's most likely not going to be an answer choice. Because this is improper, I know that I can divide top and bottom out. So 15 divided by 2 goes in there 7 times for 14 with 1 left over. Your final answer is negative 7 and 1/2. This is the answer that you're most likely going to see as an answer choice. So just once again, when you get an answer, just because you don't see it in your answer choices doesn't mean you're wrong. Chances are we just need to simplify. Now let's talk about adding rational numbers with different signs. So we know when our signs are the same, you add everything, keep your sign. But when you're adding numbers with different signs, you subtract and keep the sign of who has more. The reason we subtract is that opposites zero out. So whatever's left over is your answer. So I'm going to solve this next problem using the model first, and then we'll do it mathematically. So it says negative 5 plus 2. So I'm going to put up 5 negatives. So I have these 5 negatives, and then I'm going to add 2 positives. So I put everything up there that my problem is asking for, and now I'm going to have some stuff cancel out. So I can see that this positive and negative 1 cancel, this positive and negative 1 cancel. I'm left with 3 negatives. The answer to this problem is negative 3. So let's use that rule to solve this problem instead of the model. So negative 5 plus 2, my signs are different, I need to subtract. 5 minus 2 equals 3. If I go back and look at the original problem, I had more negatives, the answer is negative 3. So I love the counters, it really illustrates on what's canceling, but drawing counters isn't always the best strategy, especially when we're dealing with fractions and decimals. So our first example we have is 10 plus a negative 3. So we're going to do this one mathematically. I'm adding different signs. So we subtract, and I get 7. I started with more positives, the answer is positive 7. Next one, negative 5 plus 7 and 2800. Before you can add or subtract decimals, I have to make them look alike. So negative 5.00 plus 7 and 2800. All right, my signs are different. I need to subtract. 7 and 2800 minus 5, 8, 2, 2. Again, I had more positives. The answer is positive 2 and 2800. All right, our third example with fractions. Thankfully, we have common denominators, so that saves us on a step. Both of my numbers are already fractions, so I just need to follow the rule. I'm adding signs that are different. I subtract. So 5 minus 1 gives me 4 over 6. And I had more positives, so my answer is a positive 4/6. I need to simplify this answer choice. I can divide the top and the bottom by 2. Gives me a final answer of 2/3. And again, if you get this 4/6, you're not technically wrong, but chances are you're not going to see it as an answer choice. Know that if you don't see your answer, try to simplify, try to divide top and bottom out. All right, and then finally, when subtracting rational numbers. So it says, when subtracting rational numbers, it is sometimes necessary to add the opposite. A lot of our subtraction problems get confusing when we throw in our negatives and when we start subtracting more than we have. So it's often necessary to add the opposite. So our first example says negative 5 minus 3. So it says negative 5, and then it's asking me to take away 3 positives. I don't have 3 positives to take away if I'm starting with negative 5. So what we're going to do is add the opposite. So I'm going to keep my negative 5, turn my subtraction into an addition, and then opposite of 3 is negative 3. Now my signs are the same. I just add. 5 plus 3 gives me 8. and I keep my sign. -8 is your answer. So that's modeled by doing our 1, 2, 3, 4, 5 negatives. And again, the original problem said to take away 3 positives. I didn't have 3 positives. So instead of taking away 3 positives, I'm going to add 3 negatives. Your answer is your total number of counters. Let's try that on our next example. 3 minus 5. So I have 3 positives, but then it's asking me to take away 5 positives. I don't have enough positives to take away. So instead of subtracting, we're going to add the opposite. So 3 plus a -5. I can see that my signs are different. I need to subtract. 5 minus 3 is 2, and there are more negatives, -2. And that will be illustrated with the model. 1, 2, 3 positives, and then I'm going to add 1, 2, 3, 4, 5 negatives. I can see that these pairs cancel, and I'm left with 2 negatives. Finally, we're going to end on keywords. So it's great knowing how to add, subtract, multiply, and divide, but that doesn't help you if when reading a word problem, we don't know what to do. So we're going to look at a couple keywords, and I want you to fill these in as we go. And I apologize for the writing. My stylus is not super accurate. So for add, sum is a big one. Sum. Increase. Increase. Add or plus. Rise. Deposit. Ascend. Altogether. And in all. So deposit is really important when we're talking about bank accounts and statements and dealing with money. That's one that you're going to see a lot. And then ascend. This is the one that tends to trip students up every year. Ascend means to go up. Like you ascend the flight of stairs when you're going upstairs. All right, subtract. Difference. And again, I apologize for the stylus. The change, anytime you're looking for the change, you subtract. When you're finding the distance between 2 points, and that's very important on the number line dealing with those temperature questions. Withdraw, meaning to take money out of your account. And I'm going to go a little bit over into the multiply side. Descend, so to go down a flight of stairs. Minus, take away, and leftover. All right, multiplying. A big one that you may have seen on your content assessment. Product. Product means to multiply. Another big word is of. For example, you want 1/2 of the box of candy. So you'll multiply by 1/2. And then finally, times. Over here on the divide, we have quotient. Any situation where they're having you split something up or cut up or separate, repackage, regroup. And then we have a couple that go with both. Each, every, and per.